All right. So let's start this before the football starts. Yeah, it's actually good to see. It's not a full house, but very good, decent attendance here today. And we promise there'll be pizzas, more beer, and then we're going to be watching the game. But as a warm-up, let's talk about multi-tenancy and SaaS applications and how we can build this kind of architecture in AWS. Matt already introduced me, but yeah, I'm Guilherme. I'm the CTO and co-founder at Mercloud. I'm based here in London. I'm an AWS community builder. And I'm also an AI consultant. So I work with customers with their AI enablement projects and also taking those projects from POC to production. So if your company is looking for someone to help you with that AI adoption, you can just scan that QR code, connect with me on LinkedIn. So usually people come here and say, we're hiring. I kind of did a reverse pitch today. But please feel free to connect with me on LinkedIn, not only for that, to follow the content I keep sharing there. All right, so let's dive into the subject of today. What is multi-tenant? If you decide to spend some tokens and go and ask to your favorite LLM, or if you decide to do like the Stone Age people used to do and go to something called Google and search for something, you might come up with a few different answers for that. So let's try to come up with one that we can all agree on and make sense for the context of today's talk. So when we're talking about multi-tenant, we're talking about a piece of a software, a solution that we ship as a single unit. You can think about the single unit being composed of multiple servers, single servers. That doesn't really matter for the context here. What it matters is that we have one single unit that we deploy, and this single unit is going to be serving the traffic from all our different customers. And those customers is what we call them tenants. So from now on, every time I refer to a tenant, I'm actually referring to a customer of ours. Yeah? And why this is such an interesting model, and we keep hearing more and more for over a decade now. And the main answer for that is that really help us to optimize and take the most out of the available resources we have in our stack, allowing us to have better return of investment, better margins. At the end of the day, we're all building something here, an app, a platform, and we want to sell it. So we need to have a strategy that allows, can cope with the growth of our customer base, but also keeps the cost of running that infrastructure under control. It cannot just skyrocket, otherwise we're going to get bankrupt even before we are able to grow. Let's visually look at this so it will make sense. The traditional way we use to deploy software is that we have our stack. Here I'm simplifying an application with like application and data layers. We deploy that, and once we have our first customer, we deploy a stack of that. When we onboard a second tenant, a second customer, then we simply replicate that stack. We probably going to configure that slightly different to adapt to demand for that new customer, and so on. As more customers we get, more stacks we start piling up. But we can see this becoming easily a problem once we scale. We're going to end up with hundreds of those stacks. Yeah? And then we have problems with that. First, high costs, because we're duplicating stacks. It's hard to scale. We always need to create new stacks, so it's hard to update them. Imagine rolling out a deployment for a bug fix. I need to coordinate the deployment across all of those different stacks. Monitoring, observability is complicated. So we're going to look at the multi-tenant model. Yeah. So here is the same application and data layer. And then the application layer is one single unit, and we're sharing that across all of our tenants. We're looking here at the application layer because the data layer is slightly more complex. Why that's complex? Yeah. We have three competing models on that side. The first one is what we call silo. So silo, for each of our customers, each of our tenants, we're going to have an instance of that database. We have a second model that's called bridge. On bridge, we have a single instance of our database, but each of those tenants are going to have specific schema allocated inside that database instance. And then we have a third model, that's the pool, where we have one single instance of the database, one single schema, and all the tables inside that schema are shared with all of the tenants. That kind of becomes a challenge. Why? You notice that we have a tenant ID column as part of primary key of every single table. Why? Because for every record inside this database, I need to be able to identify which tenant this record belongs to. All right, so I have these three ones. So which one should I pick? And that's the classic answer. It depends. It depends on your own decisions, constraints, but also depends on the level of compliance you need to have from both your side, your customers. So what we usually end up seeing out there in the market, we have two pools. One is where we put all the tenants that they can share this kind of multi-tenancy environment. It's fine for them. And then we put all them in this group. And then for those more enterprise customers with higher regulations in terms of those requirements, then we create different stacks for them. And then we can manage our growth with that differentiation. What are the benefits of this kind of solution? So first, it's cost efficient. Why? Because we have one single unit of that, and then when we're scaling horizontally, and we're not scaling individually for a particular customer, tenant. We're scaling on the overall of the platform. Higher the demand of all of them combined, more we need to scale. It simplifies the management. We're probably going to have a single pipeline that is going to coordinate the deployment of this whole stack. So if I have a problem and I need to roll back, every tenant is going to receive that same version, that same feature when it gets deployed. And for security and compliance, it helps us to keep our policies all centralized. All right, so we get that, but we also need to go even further. So here's a visualization of over, let's say, a day or over a week of the capacity utilization of our application. So you can see here we have some spikes, and then traffic lowers down and then goes up again. To be able to cope with this demand, we need to have an auto-scaling strategy in place where we can even predict a spike and then warm up our servers, our resources beforehand, or we just react to them. This is what we usually do. But then, if you look the gap between those two lines, that's the gap where we're paying for idle time. Why I'm paying for that idle time? Just because I need to be prepared for a spike on traffic. So this is the kind of serverful way we would like to avoid and improve that. And the way we can improve that by making those lines as close as possible to each other is by going serverless. That's the model we want to go. But why serverless? It's not only because of that. Serverless really helps us to focus on the core business. Let's focus on building our products, our deployment, scaling, multi-region. Let's all delegate that to the platform, to AWS, and let's focus on our own, developing our own solution. So serverless is great for that as well. And when we talk about serverless, we have lots of components available inside AWS. We have very limited time here, so we're only going to focus on a couple of them today. And we're going to be building a simple API service here that's served by API gateway and a lambda as a backend there. And then you're going to see here in the illustrations that we have two customers, our lovely chicken and his friend Fox. And you're going to see that they're called user T1 and T2. That means that they come from different tenants. Each of them represent a user inside a different tenant in our application. The first service we're going to have a look is API Gateway. So that's the service we use for building APIs in AWS. It comes with two different flavors, REST and HTTP. And I can see some smiles there, and let's not have a discussion here, otherwise it's going to take longer than the entire World Cup. But API Gateway comes with some built-in features, for example, rate limiting that we're going to see later, and also authorizers. Authorizers, we have IAM, Cognito, JWT, and custom. Today, we're going to be focusing on the REST flavor and on custom authorizers. But what's a custom authorizer? A custom authorizer is simply a lambda where we can implement our own authorization logic. So in a multi-tenant solution, what we need to do there? We need to be able to identify the tenant from that request, and also we're going to see here sending that information to the downstream services that we're going to connect in our stack. So how it works, API Gateway is going to invoke that lambda, and then that lambda needs to return a IAM policy. And this IAM policy is going to say, okay, this particular request, what can do and what it cannot do. And API Gateway is going to simply obey what we define on that policy. And just looking a bit of code, we have there the context as well. So the context, think about metadata that we're going to be setting there, and all the services downstream are going to have access to that data. Another service we're going to look is Cognito. So Cognito, if we need user management, that's the service we use in AWS. But how do I use Cognito in a multi-tenant scenario? Then we have a few different approaches to that. The most simple is we're going to create custom attributes, and we probably want to set those attributes as read-only. So we need to set that attribute when the user is created, and then we define this is the tenant ID for this user. The second approach is a bit more flexible, is by using user groups. So each user group inside Cognito pool, it represents a tenant. So we assign users to those groups, and this is how we differentiate. This is a bit more flexible than the previous one, because this one allows us to have one user in more than one tenant at the same time in our application. But if I need to go even further, and for compliance, I need something even more flexible and isolated, then we end up with like a single user pool for each of our tenants. Okay? So this gives us full isolation, but also more flexibility in terms of configuration. Each pool can have their own user groups, their own configuration. For example, password policy. We can have it customized per tenant and not globally. How users authenticate into Cognito. So a user is going to hit some sort of UI, and is going to type their password, username and password. Cognito is going to verify those credentials, and then send back a JWT. Yeah? JWT, if you're not familiar with, I'm going to recommend you checking out this article from a good friend of mine, Luciano Mamino. He's a serverless hero. Probably you heard of that name before. He wrote a great article explaining what's a JWT, how it works, how it's composed. But let's say it's a token that we receive back from Cognito. And then our users are going to be using that token to call our API, saying, here are my credentials. Yeah? API gateway is going to validate the token. If everything is OK, it's going to forward that request to our backend service. And all the data flow is going to get all the way back to the user. Let's look at the compute layer. So what we have so far are users, they get a token. They use that token to call our API. There's the authorizer that validates that token, and then calls our lambda. That's our backend. Very simple here. And then this lambda is going to access data. Okay, so let's focus on that specific point. And you can see that we have two data stores there. One is DynamoDB, and another is S3. And as you can see, we have data from both tenants in both of the stores, the same resources. And this is very critical. This is what we call the danger zone. Yeah. Why this is called the danger zone? Because if anything goes wrong on that layer, we're going to be leaking data. We have a request from tenant 1, and then we get data from tenant 2, and then we end up leaking that data. Yeah? This is so critical that depending on what kind of customers, what kind of industry you are, for example, finance, this can take your business out on the same day. This is very critical. So let's picture that. Let's see visually what that actually means. Yeah? So this is our DynamoDB table, and this is our S3 bucket. And you can see that we identify the tenant of each of those records in DynamoDB by a column, by a partition key, and in S3 by a path, by a key in our path. What happens when our lambda is accessing that DynamoDB table? Yeah? So you probably know that lambda comes with 0 permissions, and then we need to create policies to allow that lambda, that resource, to access something. So here we're creating one where we allow this lambda to do a get or a query, read-only operation, on that specific table, the catalog table. And how this looks as a code. Yeah, so we instantiated a DynamoDB client there. Then we have some logic where we extract the tenant from that request, from the headers, for example. And then we use that variable, the value of that variable, as a filter to a query in DynamoDB. And here's the problem. What happens if anything goes wrong with the implementation of the logic that captures the tenant from the request? That's the only thing that's telling us, okay, filter this data is that variable value. So what happens there? Let's say that lambda gets compromised by either a bug or manipulation, security concern there. So the lambda is going to get manipulated. That request is actually going to diverge, trying to access data from a different tenant. And then that request is going to get impersonated and access data from a different tenant. There's nothing there that's preventing this from happening. apart from that variable value. So how can we stop this? And what we're going to be looking today is how we can take that burden out of this lambda and delegate to the platform. And here we're going to be looking how we can delegate that to the authorizer itself. How are we going to do that? How that authorizer code looks like. So the first part is where we validate that token that we received from the request. And under the hood, how this happens, right? So we get the token on the headers. So Cognito, we're going to fetch the public keys from Cognito. If you don't know, that is a well-known location, public location you can ping. It's going to return you a JSON like that, where you have an identification and the public key for each of those values. If everything is okay, then this function gives us a thumbs up. And then from now on, we can trust that token. So everything that's on the claims of that token, we can trust. It's being validated. It hasn't been manipulated at all. Second part, we're going to be assuming a session here. Creating a session by assuming a role. And this role is something that we created as part of infrastructure as code. And I'm going to catch your attention here to two specific points. The first one are those statements. On those statements, we're restricting who, what resource in our entire AWS account can use that role. And here we're saying that the only that can use that role is our authorizer itself. And then the second part is where we define the boundaries for this role. So everything that anyone with those credentials can access. And here we're saying this role can do read or write operation in any of the DynamoDB tables on this stack. The second part here on the assume role command is an inline policy. So this inline policy is where we scope down those boundaries for this particular request. So here, for example, we're saying, okay, within those boundaries for this particular request, you can only do a query on this products table. And this is the part where, depending on the user role or permissions, you can add more or less permissions here. And a very special thing here, a condition. So if you look at the condition, you say, okay, you can query this table under a certain condition. You can only query if the leading keys, that means the partition key, your primary key, for those not used to DynamoDB, if that matches a specific tag, principal tag / tenant ID. And that's a tag that we set in there on the session, using the value that we extracted from the token we just validated. So if anyone tries to manipulate that filter now, that value is not going to match with what's on the session. So the platform is going to block that request. The next part of the authorizer code is where we define that policy. And here is a very simple one. Say you can only do a get on the / request, on the / path. And then as part of the return, we do the policy, and also we set this context. So this context is what we're going to be metadata information that we're going to be providing for the downstream services. And here we say, okay, the tenant ID and also the credentials for that session we just created by assuming that role. Now we can refactor our code. So we're going to extract the context metadata from the request, and if you're using Lambda, it's under that context parameter you receive on your Lambda invocation. And now when I create an instance of my DynamoDB client, I'm going to be creating that instance using the credentials that I received from the metadata. And now I can safely do that filter expression, because if this gets manipulated anyhow is not gonna match, the tenant ID is not gonna match with the session tag that the authorizer created. So if we look again, so the authorizer is setting those credentials on the context. If this gets manipulated by a bug, by any other mean, and that request tries to access data from tenants 2, that's gonna get blocked. The platform is gonna ensure that. So it's no longer responsibility of the Lambda to handle that scenario anymore. Okay, so we solved the data access path, but what about the Lambda environment itself? Because every invocation we have from our Lambda, it creates an execution environment. But if I have multiple tenants consuming that same Lambda, so we might end up reusing an execution environment that was created from a request from another tenant for the second tenant. And that might get problems because we can save something on the global scope and then we can access that across invocations. Some people use that as a free memory, cache memory. Yeah, there's nothing wrong with that. But on a highly controlled environment where compliance hits, that's a problem. So how do we solve that problem? And historically, how we solve that was by creating different Lambda functions for each of the tenants. But that's not scalable. Otherwise, I have 100 customers, I need 100 Lambdas. And then last year, just before reInvent, AWS released isolation, where you just send a parameter, and then Lambda itself handles that for you. What about other resources? We looked here at DynamoDB, but if you're using S3, Cloud Search, you can do something very similar, the same approach. And if you're on Aurora Postgres, you can do something similar by working with row-level security, and that works pretty fine with the data API if that's the way you access your serverless database. Other resources, then you're kind of on your own. You either do separate instances per tenant or you do code-based checks where it's possible. Another problem that we have is classic in multi-tenant scenarios is the noisy tenant. Yeah? The tenant that suddenly has a spike on data and then ends up affecting the overall performance of the application, affecting other tenants that have nothing to do with that. So API Gateway can help us with API keys and usage plans. Let's have a look at that. So what we're proposing here on our stack is that we introduce a new DynamoDB table here. And then on that DynamoDB table, we're going to be storing an API key for each of our tenants. This API key is something that we create at the time that we're onboarding that new customer. We create the API key and then we assign. And what happens? So if we look back at our authorizer code, we're going to have two extra steps there. One is a logic to fetch that key from this new table. And then on the response, we're going to be adding that key, usage identifier key. So by doing that, that key is going to be sent back to API Gateway. And API Gateway is going to control access, applying throttling and usage limits on according to that key for us. So it's going to be doing the filtering. But in multi-tenant, we need to understand that each tenant comes with a different persona. And each tenant have different usage patterns and different sizes. So you might have small customers, you might have medium customers, you might have large customers, or you might have that large enterprise that's so big that's gonna make your application fail. How do we allocate different limits according to the tenant? Then we can use usage plans. So usage plans, we can configure them individually, and then we assign our tenants to a usage plan, and then API Gateway is going to respect those when applying throttling and limits on our requests. Wrapping up. Yeah, I'm watching. Yeah, so yeah, we saw that serverless has all the building blocks that we need to build multi-tenant solutions. We don't need to reinvent the wheel here. It helps us to accelerate adoption, but data isolation is very critical for security and compliance. Each tenant comes with that different persona, and we don't have time here to go through observability, but observability is a must. And this observability needs to be tenant aware. Why? When something goes wrong, I need to quickly be able to identify who is using what and how much of that they're using. And of course, don't try to do early optimization, especially in this kind of scenario. You're going to do it wrong. So use metrics to drive where you need to optimize. There's a great, it's a bit outdated, it's from 2022 reInvent, but it's still super up to date in terms of content. If you want to dive into this subject, how to optimize multi-tenant architectures, it's available on YouTube. Some additional resources, if you want more content on that, shout out to the Well-Architected framework. There's a whole category there on SaaS. I recently wrote a deep dive on multi-tenancy and serverless for the community quarter newsletter. If you're not signed up, click on that QR code and read the article and sign up for the newsletter. And just before I finish, yeah. The slides are available on that QR code if you want to grab them. Yeah, thank you.